This is Mr. Beck Does Your Homework, AP Physics, Homework 9.2, question number 15, 16, 17, 18, 19, and 20, all based upon this picture right here. This gives you two charges. It gives you some object A over here. And the first question says object A is most likely. Well, if you look at the electric field lines, you notice that all the electric field lines are perpendicular when they hit this object. Well, one of the rules we have is that for a conductor, all E field lines that go in or out of a conductor are going to be perpendicular. So all E field lines are perpendicular to a conductor. So that should answer that question. And the reason being that since it's a conductor, it's got free electrons that are free to move along the surface. If there was an E field on the surface, then those electrons would move one way or another, and they move until the E field doesn't have any left or right movement on them, any left or right force on the charges. So the charges will rearrange so that all the lines are perpendicular to the conductor. So that answers number 15. Number 16 says, what is the ratio Q1 over Q2 of charges Q1 and Q2? Well, another thing we know is that the number of lines is related to the amount of charge. So what you want to do, if you want to find the ratio of Q1 over Q2, well, you will count the number of lines in and out of Q1. 1, 2, 3, 4, 5, 6, and so on. You will count the number of lines out of Q2. 1, 2, 3, 4. So once you do that, the other thing is that you have to pay attention to positives and negatives, because Q1 has lines going out of it and Q2 has lines going into it. So I know that electric field lines go out of positive into negative. So the lines go out of positive and into negative. So this one has lines going out of it, so this is going to be a positive on the top. This one has lines going into it, so this is going to be a negative on the bottom. So when you do Q1 over Q2, the ratio is not going to be an absolute value, but it's actually going to be a positive or negative number, and positive or negative is going to give me some negative answer. So it's going to be negative some answer. And then again, it's count the lines, that's your ratio. Where is the potential the largest? The potential is the potential to have energy, how much energy it would take to bring a charge all the way there. And so my potential is going to be the sum of all the, or K times the sum of all the Q's over R's. So KQ over R. So the potential is going to be the greatest near a positive charge. So if I think about moving a charge from infinity closer and closer and closer and closer and closer, 1 is pretty far away from both charges, not much potential there. 2 is close to a negative, you'd almost have negative potential there, but 3 is really close to that positive. So the closer you get to the positive, the more energy it takes to push the charge to that location. A negatively charged particle placed at point 3 would do what? Well, a positive charge would go in the direction that the field goes. A negative charge would go opposite the direction of the field lines. So I'll let you figure out what direction the force would be on a charge placed there. Number 19 says, where is the electric field the smallest? So wait, for number 18, the rule would be that the lines point in the direction that a positive would feel a force. A positive would feel a force. So when we say where's the electric field the smallest, the rule there we need to know is that the density of the lines or the closeness of the lines is related to the strength of the field. So more lines, a stronger field. So if you look at these points, where are there the most lines? So that's one thing you need, is the density is related to the strength of the field. The other thing you need to know is that there's no E field inside a conductor. The reason being, if there was, the charges would move around. And as the charges move around, they move around to get rid of the E field. I'm kind of running out of space there. So no E field inside a conductor will tell you that the electric field is going to be the smallest, not where there are the least number of lines, but probably where inside the conductor is where I've got absolutely the least. But I don't know if that's one of the options. I cut off those multiple choice answers. Now it says, what is the potential at point 4? Since there's no E field at point 4, I'll let you figure out what the potential needs to be at point 4, but I'm going to go with 0.